Generally, we're going to be solving a system of two linear equations. You're going to see x to the first power and y to the first power somewhere in your equations. If you put in numbers for these a's and b's and c's and d's, it might look something like this. You have one equation that is, 2x minus 3y equals 6, let's say. And then another one is x minus 2y or plus 2y equals 10 or something like that. And each one of these is a line. So if you were to graph both of those lines, I'm not sure what it would look like, but maybe it would look like that, and those two lines would be intersecting. And so what it means to solve a system of equations that have two lines like this is you're looking for the coordinates of the point, the xy ordered pair, that appears in both of those lines. So it's only that point right there that is a point on both lines. It's the common point. It's the one you're looking for. So that's the problem for today. Now later on, we're going to bump it up to 3 dimensions, and we're going to have 3 variables and 3 equations. And we're going to look at several techniques to actually solve this. So in this section, they identify the different scenarios for a 2x2 system. And they tell you that there's going to be one of 3 things that happen. And the first thing is, you graph the first line, and then you graph the second line, and you can see that the point of intersection is right there. So if you have intersecting lines, you'll have one solution. This is the way most of these problems will be of this sort right here. And then, so the answer is some ordered pair, x, y. In my example here, maybe this point is, say, -3, -1. And then we would write -3, -1 as the solution. In the next scenario of graphing 2 lines, you could have one line that looks like that, and then the other line that looks like that. And forgive my picture, but just imagine that these are parallel lines. And if they're parallel lines, they'll never intersect. They have different y-intercepts. And so in our quest to find this common point, there are no common points in a situation like this. So we're going to say no solutions. Our solution would be an ordered pair generally, or all the ordered pairs that work in both equations. And since there are none, we'll say no solutions. And sometimes we use the word inconsistent, an inconsistent system. So as we go through these problems, just know that there's going to be one of these 3 different types. The third type might be something like this, where we graph the first equation, and then we graph the other equation. And interestingly enough, the other equation gives us a line that's exactly the same thing as the first line. So we have identical lines. The equations could look quite different, yet they give you the same lines. If we're looking for common points, then any point that's on one line is also on the other because they're identical lines. So in this case, we would say infinite solutions. Sometimes we use the word dependent. Dependent solutions. There are an infinite number of solutions. The value of x or the value of y depends on the value of x chosen. And usually we'll write the solution in set notation. Solutions equal the set of all ordered pairs x, y, and then a vertical line, which means such that. And then we would just give, the equation of one of our lines, such that the ordered pair works in there. All right, so those are the 3 scenarios. And, maybe we'll do the algebraic approach and some other approaches to see, what happens to get each of those. And here's the verbiage that I described earlier, the consistent and the dependent and so on, the inconsistent, all of that. So this one here is more related to later on when we start doing matrix operations. But what they're saying here is that if you have a system of 2x2 equations, and let's say that it looks like this one here for number 18. Let's use this as our base equation. There's one solution to this one. And what they're saying is that if the two equations are interchanged, and let's say you put x plus 3y equals 12 and y equals x minus 4, that is, you switch the position. And then you ask, what are the solutions of this system of inequalities? Well, the solution here is the same as the solution here. Doesn't matter what equation is on top. Each equation represents a line. Two different lines. We're looking for the point of intersection. So the solution of this guy is the same as the solution of this guy. All right, this one here. An equation, one of the equations, is multiplied by a non-zero constant. So let me multiply the second equation by 5. If I keep the first equation the same, and I multiply the second equation by 5, I would get 5x plus 15y equals 60. What they're saying is that if you just multiply one equation by a number like this, the solution that you get to this new system will be identical to the solution that you get from the original system. So all of these have the same solution. And then the last one is a little bit more complicated, but if we multiply the second equation by 5 and then add it to the first equation and come up with a new, let's say we have y equals x minus 4 is one of our equations, but then to get our second equation, we're going to multiply by 5 and then add it to this equation here. So if we took 5x plus 15y equals 60, and then added it to the first equation, negative x plus y equals negative 4, we would generate this new equation here that would look like 4x plus 16y equals 56. If we combine these two together, the solution of this system will be the same as the solution of this system. Anyways, we can manipulate one or two of the equations in these three ways, and we can have the same solution as the original. And this becomes more important when we get into matrices, but so it might just seem like common sense to you, which maybe it is. All right, so what they take you through here are some algebraic solutions. There's the substitution method, and there's the elimination by addition method. And then we'll look at a matrix method. All right, so here's 20. So maybe we'll use this as our first example in the substitution method. Generally, the substitution method is one you'll want to use if one of the equations is solved for one of the variables. Like this is a good candidate. This is a good candidate. 20 is maybe not as good because you don't have y equals everything else, or you don't have x equals anything else. But what we can do is we can solve this equation here for y. And if we solve that equation for y, I will add y to both sides, and then I'll subtract 7. And that would get y by itself. And if I put y to the left, here's an equation. So these two equations, they look different, but all we did to go from one to the other is just apply a little bit of algebra. So they're equivalent. So they're going to give you the same solutions. Okay, now in the substitution method, we're going to substitute or replace one thing for something that's equal to it. So you'll notice in this equation, y is equal to 3x minus 7. So the technique here says, oh, did I write this wrong? 3, 7, 7. Oh, this has got to be a 2 here. 2x plus 3y equals 1. We're going to take the second equation And since this equation over here tells us that y is equal to 3x minus 7, what we're going to do is we're going to replace the y in the second equation with 3x minus 7. It would then look like this. Notice I wrote the same exact equation, 2 times x, 3 times y, but I replaced the y with 3x minus 7. All right, I'm going to go quickly through this algebra, but this is what you would have to do. Be sure to use the distributive property correctly. Combine the like terms, put the 21 over there. You'd have to add 21 to both sides, and then divide by 11 to get x is equal to 2. In these algebraic methods, this is kind of what's going to happen. You're going to find one of the values of the, you're looking for an ordered pair as your answer. But instead of finding them both at the same time, you're going to find them one at a time. So the x coordinate is 2. And since we're looking for an ordered pair solution, we still have to find the y. So what we'll do is come up to one of our equations or one of our equivalent equations, and then we'll note, well, if x is in fact equal to 2, which is what this says, then we replace the 2 in for the x. So once again, we are going to substitute. In this case, the substitution comes here. We're going to replace the x with its numerical value 2. That's 6 minus 7, or negative 1. And so our answer is 2, negative 1. And while we're here, I'm just going to solve this one. All of these problems you can solve, if you get good at it, in a matter of 30 seconds with your calculator. So you may recall the graphical method for solving these. So what we're going to do is we're going to take the first equation, 3x minus y equals 7, and up above I converted it using some algebraic steps to be y equals 3x minus 7. I'm going to take the other equation, 2x plus 3y equals 1. I'm going to solve this one for y as well. And the reason we have to solve for y is because when we enter in equations into the calculator only understands y equals something. So we have to solve for y and just put everything else in here. The first one we're going to put in is this one, 3x minus 7. All right, now I have to put this one down here in the same format. All right, so I'll subtract 2x from both sides. This is kind of algebra that you're used to. Clean up the equation after each step, and then we're going to divide by 3. Divide every term by 3. So y equals negative 2/3 x plus 1/3. And you can use an equivalent version of that. Now, when I use the graphing calculator, I'm going to let my first y to be y1 and my second equation be y2. All right, so I've already got y1 entered in there. Now I'm going to enter in y2. Everywhere I see a fraction, I'll just put it in parentheses. And that avoids a lot of the order of operation errors. So negative 2 divided by 3 is how I'll write the fraction negative 2/3. Then I need the x. X is right here, x. And then plus 1/3. So if you put each fraction in parentheses, then you're pretty safe with the order of operations. All right, and so the calculator has both of these lines with the equal signs highlighted. That means they're active. I can't just hit graph here because I used some other viewing rectangle in my last example. So I'm just going to do zoom and then standard. The standard viewing rectangle is the one that converts the dimensions of the viewing window negative negative 10 to 10, negative 10 to 10. Standard 6. Here's the first line. There's the second line. And guess what that point is? It has to be, right? We just solved them using two different techniques, but we're really looking for the same common point. That's 2, negative 1. All right, so let's find that point of intersection using the functions of the calculator. We want to calculate something. So right above the trace key is calculate. It's in blue, so to access that menu, you have to hit the second key first, which is also blue. So second, we've already used this value 1. The one we want in this problem is intersect. We want to find the intersection between those two lines. So we're going to select number 5. And then it's going to give you 3 prompts. It's going to ask you for the first curve. It's going to ask you for the second curve. And it's going to ask you for a guess. Generally, all you have to do here is hit enter 3 times. Enter the first time to hit the first curve. Enter the second time to select the second curve. And then if there's just one point of intersection here, then you can just let your guess be wherever the cursor is. And eventually it'll find it. So I'm just going to hit enter, enter, enter. And notice it goes right to that point and it gives you the coordinates down here of that point of intersection. The graphing method, if you can enter the equations in incorrectly, sometimes you have to manipulate them to get them in the right form. But the graphing calculator method is very quick and very accurate. So second trace, that gives you calc. That gives you something to calculate. Then after that, you want to go down to option 5, which is the intersect. Select that one. And I think most of the time in this one, just hit enter, select the first curve, enter to select the second curve, enter to give the calculator a guess, and then it reports the solution. First curve, second curve, and then guess. Okay, let's take a look at another technique. So we've got the substitution method and we've got the graphing method. And this next method I want to illustrate, I'm going to do another problem and I'm going to use what they call the elimination by addition method. And let's take a look at number 24. What we're going to be using in this technique is their part C there. What they're saying here is that you can multiply one equation by a number and then add it to another equation. And if you do that, you're going to get the same system. You're going to get the same solutions. So in the elimination method, we're really applying this number C here. So let me show you how it works with a problem. In 24, we have 2x plus 3 equals 1 and 3x minus y equals 7. Now you can get good at this, and I just want to do it just to show you that how nice the graphing method is. It really does take just 30 seconds to do these problems, but you have to convert this to y. So I'm going to start with 1. I'm going to bring the 2x over, minus 2x, and then I need to divide by 3. So that's what the first equation could look like. Notice I didn't do any algebraic simplification. I just brought the 2x over, which would make it negative, and then divided by the 3 to get this one here. 7 is over there. I'm going to bring the 3x over, making it minus 3x. And then I have to divide by the number in front of the y, which is negative 1. Graph, second, calculate, 5, enter, enter, enter. So this one also, the solution of our first one, wasn't that 2, negative 1? No, maybe it wasn't. Okay, let's take a look. I notice here that this is negative 1, the coefficient in front of the y, and there's a 3. If I multiply the second equation by 3, 3 times negative 1 is going to be negative 3. The negative 3 will match, except they're opposites, the positive 3. Then I can add the two equations. So I'm going to multiply one equation by a number and then add it to another equation. That's a legal step. That's going to lead to the same solutions. All right, so I'm going to create a new problem. The first equation, I'm going to leave alone, do nothing to it. But the second equation, I'm going to multiply every one of the terms by 3. 3 times 3x, 9x. 3 times negative y, negative 3y, and 3 times 7 is 21. All right, so I've multiplied an equation by something, and now I'm going to add two equations together. But what's nice here is that when I add these three y terms together, one's positive and one's negative, they'll be equal to 0y, which is just 0. So what happens is that we eliminate the y variable in our algebra here, leaving just 11x equals 22. Man, this looks familiar. So it feels like I'm doing the same problem. So x equals 2. All right, now we're going to take one of these two equations. It doesn't matter which one. If I take 3x minus y equals 7, and then I replace the x with 2, substitute in 3x means 3 times x, so I have to multiply 3 times 2, and then work out the algebra. Subtract 6 from both sides, and then multiply by negative 1. Okay, and you put this x and this y together, and you get 2, negative 1. So whether we do it by elimination or we do it by graphing calculator, the answer has to be the same. Elimination method. One more method, and this one I think you'll like. This is going to be the matrix method. For 2x2 systems, one of those three approaches would work. The algebraic approaches, if you go up a dimension and you look at 3 equations with 3 variables and you want to find the order triple that's common to all 3, the algebraic methods just become too tedious. So we're going to be looking for another way to do a problem. So let's see here. I can just grab one of these. How about number 54 is down here? They wanted you to solve this using your graphing calculator. And again, if you use your graphing calculator and you know how to type things in, it takes 30 seconds to do the problem. It takes you the time to type in y1, takes you the time to type in y2, and then second intersection, enter, 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 and bang, you've got the solution. All right, let me write down this problem. 54. It is 3x minus 7y equals negative 20, and 2x plus 5y equals 8. I think that's it. Now, if you have a preferred technique, you know, if we're doing tests and so on, I'm not going to say that you have to solve it using this method or you have to solve it using this method. I'm just going to say solve it. So if you want to use the graphing calculator method, you can. If you want to use elimination, you can. If you want to use substitution, you can. So again, I'm going to walk this through. We've got negative 20 on the left. I'm going to bring the 3x over. And then finally, I'm going to divide by negative 7. I don't have to do any algebraic simplification just in order to enter in the equation. And the calculator, it doesn't care if your equation is messy or it's nice and tidy. It'll do it. It'll do the problem no matter what formats it's in. So 8 is over here. I'm going to subtract the 2x to bring it on over. Close that parenthesis. And then I got to divide by 5. And then graph. And then second 5 intersection, enter, enter, enter. And okay, it's not that nice. But so it didn't work out to a nice whole number there. But here's what you can do. The calculator stores this x value. It stores this y value. So if you wanted the exact value, the fractional versions, what you could do is go to your home screen, convert x to a fraction, and then you can convert y to a fraction. So let me write down the answer here. And then I'm going to go convert these numbers to fractions. So negative 1.517241. and 2.2068966. All right, I'm going to go back to the home screen and I'm going to type in x because it stores the x coordinate of my point in there. If I just hit enter, there it is. All right, now in the math menu, there's this function that says convert to a fraction. So let's take that number and convert it to a fraction. Oh, there it is. Turns out that that fraction number there is actually negative 44 over 29. In terms of y, all of the alphanumeric number or letters are in green above the keys. So if you want to find y, you can see it right there in green. In order to access the y, since it is green, you have to hit the alpha green key to get it. So I'm going to hit alpha and then the number 1. And then you can see the variable y goes to my screen. And if I hit enter here, you'll see that it gives me this number. But then I want to convert that to a fraction, and it's 64 over 29. So the answer is not nice here, but the calculator can handle it. It gives you decimals as a default, but you can convert those decimals to fractions. All right, let me show you the matrix method. And what we're going to do is we're going to create this augmented matrix. It's actually the same thing that you see here, but we're going to get rid of all the x's and the y's and the equal sign. So if you just got rid of the x's and the y's and the equal sign, you would have this matrix, and for matrices, we use square brackets like this. And a matrix is a rectangular array of numbers. So we're just going to take the coefficients. Where you see a subtraction sign, we're going to put the subtraction sign and think of it as plus negative 7y. So the coefficient in front of the y, we're going to think of that as negative 7. And then negative 20. Those negative signs are important. And then the bottom row would be 2 and 5 and 8. Again, this method is not as powerful when we're working with smaller systems 2x2s because we've got lots of methods to do it. It's when they go up to 3x3 systems that this matrix method is really, really useful, as you'll see. All right, the calculator will convert to this new format. And the format is called the reduced row echelon form. All right, just a bunch of fancy numbers, but the reduced row echelon form will put the matrix in a format so you have 1, 0, 0, 1, and then the x coordinate of the solution there and the y coordinate of the solution there. So if the calculator takes this matrix and puts it into this format here, which is the reduced row echelon form, if you use an acronym, reduced row echelon form, if you apply this function, it'll convert your matrix to this format. And then the answer is in the last column. Here's the idea. This is your X column, and this is your Y column, and this one I'm going to call the right-hand side. And so you 3x minus 7y equals 20. That's the first equation. 2x plus 5y equals 8. And that's the second equation. In this problem here, if say we had negative 2 here and 3 here in the matrix, then the same columns apply here. If we can somehow put our original matrix in this format, then look what we have. We have 1x plus 0y equals negative 2. Well, that just simplifies. X equals negative 2. Gives us our x coordinate. The second equation is 0x plus 1y equals 3. Well, if you simplify that whole equation, you get y equals 3. That's why the solution is over here in this last column, if you have 1, 0, 0, 1. All right, so let's walk through this. And I'll take you through the steps of how the calculator does this. So the first thing you want to do is to enter in this matrix. Now there are 2 rows and 3 columns. So the dimensions are 2 by 3. For a matrix, we always lists the dimensions of the matrix with the number of rows first. So the number of rows by the number of columns. 2 rows, 3 columns. When you're entering a matrix, you have to tell it what the dimensions are so it knows how many blanks to allow you to type in. Right above the math menu, or right below the math menu, right above the x to the -1, you see the matrix where we're going to enter and do all the operations on matrices that we have here. It's in blue, so I have to hit the blue key first. So second, and then x to the -1. This is what the matrix menu looks like. Yours is going to look a little different than mine probably. For you, maybe all of these will be blank because you haven't entered matrices in before. But you have the names are A, B, C, all the way up to G. It looks like there's even more down there. This math menu is where we want to do math functions to the matrices. Edit, just like when we type in edit when we're entering data, edit really means on the calculator that we're going to edit the data list, or in this case, edit the matrix. So move over to matrix. This is the first thing you want to do, and then select one of them. I always just select matrix A. Notice that currently my matrix A is a 3x3 matrix. So hit enter, and it says matrix A. This is how it looks. You notice 3 rows, 3 columns. I want my matrix to be 2x3. So I have to hit the number 2 and then enter, and then number 3 and enter. And then notice that it creates spots. 2 rows and 3 columns worth of spots. All right, now I'm going to enter in this guy. And the way you enter them in is just you enter in each number and hit enter. It's going to go along the first row and then bounce down to the second row. So 3, enter, -7, enter, -20, enter, and then it jumps down to the next row. 2, enter, 5, enter, 8, enter. Okay, so the only way to get out of this menu here is to quit and go back to the home screen. And quit is right above the mode key. It's in blue. So if you ever want to go back to your home screen, second, quit, or second mode. Now I know that the matrix is in there, the one that I want. And so now I'm going to go apply a math function. The math function I want to apply is in the math menu. Notice my matrix A now is a 2x3 matrix. It changed it for me. And now all of you should also see next to matrix A, 2x3. Math. And I'm going to scroll down, and this is what I'm looking for. RREF. That's the function that will convert my original matrix into that special format. And there it is. For me, it's option B, RREF, reduced row echelon form. All right, I have to tell it which matrix I want it to convert to that format. So I have to go back into the matrix menu. The only place where the matrix variables will be found is inside the matrix menu. And so under names, I'm just going to select matrix A. And this is what it would look like on the screen. So convert matrix A, which is the one I just entered in, into the reduced row echelon format. Hit enter, and notice you'll see 1, 0, 0, 1. And remember these numbers from our earlier problem here? We did it by graphing calculator, by the graphing method. So there you see them. And this is interesting because if you wanted to then math convert that last answer was a matrix. So what does it mean to convert the matrix to a fraction? Oh, I see. It converts every single number in the matrix, if it can, to a fraction. So you can see our converted fraction format as well.